Morning, guys. Let's see here. Close other apps. Cool. There we go. All right. One band streaming video. All right, guys, man, this is when we start getting into the real life here. Let's focus this. All right, so this is kind of the last half of chapter 1. This is when we're talking about exponents, like kind of more in depth. We talked about them a little bit so far when we were doing, squares and cube roots and stuff like that. Sorry, it's an awkward time to take a drink. But now we're going to really kind of dive into it and what we can do and how we can manipulate those exponents. So we've got this band streaming video concert to benefit a global charity. Costs $1 to view. Look at this cool guy doing air guitar right there with his AirPods. Man, that rocks. Actually, they're wired in. He doesn't even have AirPods. The first day, the concert got 2,187 views. The second day, it got about 3 times as many views. On the third, it got 3 times as many views on day 2, and so on. So if the trend continues, how much money will the band have raised in 1 week? If you want to pause this and kind of work that out on your own, that'd be great. Kind of double check your work right there. But if we have, I'm just going to kind of break this down into a table, right? I'm just going to say day 1, they made 2187. Right, 87? Yeah. Okay. And then day 2, they made 3 times that. So 3 times 2187. And guys, I'm just going to use a calculator for this. So 2187 times 3 gets you to 6561. Okay, so that's day 2 right there. Now day 3, man, I may not have enough room. I may have to go in the second row for this. That's unfortunate. So day 3, basically, they make 3 times what they made the previous day, and kind of that's the pattern that continues, right? So it's 3 times 6561, and I can just actually say times 3 right there, and brings us to 19,683. Man, this band is donating all of their money to charity. That's pretty philanthropic of them. I bet when they saw how much money they were making, they're like, oh, dang, we should have taken a portion of that for ourselves so we could have bought a new tour van or whatever. And so then they take that for day 4 and they multiply by 3 and they get 59,000. Man, in 4 days, gosh, this band is pretty popular. And then I'm going to move down here, right? So day 5, they take what they made the previous day, that 59,000, right? And they multiply that by 3. Hopefully you can see kind of how the pattern works here, guys. We take that 59,049. Nope. I cleared it out. Let's see, 59,049 times 3. That gets us to $177,147. And then on day 6, right, they take that 3 and they multiply it by that 177,147 right there. Let me just say times. It takes the answer and multiplies it by 3, which is 531,441 doll hairs. No, dollars, not doll hairs. That's a silly thing to say. Wish I. And then they take that last day and they say 531,000 and they multiply it by 3 for the last day of this little kind of experiment. So that's going to be in the millions, right? So that's 1,594,000. And what is that? 323. Yeah. So that's the idea here, right? They were basically tripling it every day. Triple. Okay. Yeah. I don't know what to say beyond that. That's kind of how it works. Okay, now we're going to dive into exponents today. So this is a very simple exponent right here. We have this x, this is the variable, and we have it squared right here. Now, a couple things we need to, or a couple vocabulary words we need to kind of have common for everybody. The little number right there is called an exponent, and then the big number is called the base. So the base is the big number, the exponent is a smaller number. Now, I see a lot of students write stuff like this, where it's just x and 2, and like the 2 is like as big as the x. Don't do that. That's not how we do this, guys. If you're writing an exponent, it needs to be kind of elevated and smaller, right? No, please don't do that. That's amateur hour, right? I don't like that. It makes me feel sad when students do that. Okay. So there are a few kind of rules here, 5 or 6, I guess, depending on how you break it down. But yeah, example number 1 kind of talks about the first one. I have talked about this in the past as the product rule. You can say product of a power if you want. But yeah, okay. So we have the average weight of a newborn male caribou. Oh, look at that. Yeah, right there is 2 cubed pounds. On average, the adult male caribou weighs up to 2.6 times more. That's kind of an important thing. More than a newborn. How can you determine the average weight of an adult male caribou? Well, so the idea here is we're going to take this 2 cubed, and we're going to be multiplying it by that 2 to the 6th. That's what that more means, is you kind of multiply them together. So I'm going to take this 2 cubed, right? And I multiply by 2 to the 6th. And the idea here is when you are multiplying exponential expressions with the same base, right? They have the same base, that 2 and that 2, same base. So let me highlight that. When they have the same base and you're multiplying them together, all you do is add the exponents and keep the base. So I'm going to just put a little bullet point right here. You add your exponents and you keep the base the same. Okay, so when you're multiplying them like this, right? So we keep the base the same, so it's going to be 2, right? And then we need to break this down, right? So we kind of add those 2 together. So it becomes 2 to the 3 plus 6, which is 2 to the 9th. Which if we actually put that in our calculator to see what it is, which I'm not going to stress about that kind of during this part of it, but 2 to the 9th is 512 pounds. So yeah, that's the average weight of an adult male caribou is over 500 pounds. Yeah, I don't know. I'm going to kind of expand this out. I've got 3 2s and I have 6 2s right here. But that's your answer right there. If you have kind of trouble visualizing that, we can break this down, because this 2 cubed means that I'm taking 2 and I'm multiplying it by itself 3 times. That's what that 2 cubed means right here, right? Okay, now this 2 to the 6th means that we're doing the same thing, but we have 6 2s. 2, 3, 4, 5, 6. Right? So now we just count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where that 9 comes from, kind of an expanded form, kind of a different way to visualize that. So that's the idea right there. And let me emphasize that this is your answer. Let me highlight the pink. I like pink right here for this. That 2 to the 9th, that is your answer, right? So when you are multiplying the exponential expressions, right? These are exponential expressions. It's 2 cubed, not 2 6ths. And they have the same base. You just add your exponents, right? So yeah, example 2, multiply exponential expressions, different base. Oh my. I didn't put anything in there. It's a big old typo on Mr. Wishart's part here. Let's see here. Can I pause this for a moment? All right, guys, we're back. Sorry, when I was putting these notes together, I actually kind of took away too much information. So the idea here is we're going to find the volume. And sorry if my handwriting is terrible. That's just how it is. In cubic inches of a cube with an edge length of 2 feet. There we go. Okay. And so we kind of have this as a little guide as to how to start this, right? So if it's 1 cubic feet, right? 1 cubic foot kind of in dimensions, right? Then that means it's 12 cubic inches, right? So 1 cubic foot, because there's 12 inches in a foot, so it's 12 cubed right there. So if we have our volume of our original cube, right, we know it has an edge length of 2 feet, so that's our volume is 2 cubed. Okay, and if 1 cubic foot is 12 inches, right? So then we can kind of combine this to be, sorry, I keep thinking something's going to come in my room in just a second here. We can actually take that 2 cubed and we can multiply it by the 12 cubed to kind of convert it to inches, right? Because that's how you work it, right? If you have 1 foot and you want to find out how many inches, well, you multiply by 12. So 1 foot times 12 is 12 inches, right? So if you have 2 feet, we're multiplying by 12 inches to get it to inches, right? And since we're doing volume, we're just kind of cubing each one, right? And so the idea here is we're multiplying exponential expressions, but in this one we have a different base, right? Same exponents, different base. And so this becomes, I'm going to do this kind of an expanded form like this so we can kind of see it. So this 2 cubed becomes 2 times 2 times 2, and this 12 becomes 12 times 12 times 12. And so we can kind of combine these together to get the actual individual inches, right? So we can say 2 times 12 times 2 times 12 times 2 times 12, right? 2 times 12 is 24, right? Just like that. And there are 3 of them, so you get to 24 cubed. Okay, so when you have exponential expressions with the same exponent but different bases, right? So I'm going to write here same exponent, if I can type it correctly, write it correctly, but different bases. Okay, I'm going to separate that out here. You keep the exponent the same. It's kind of the opposite of the first example. Keep the exponent the same, and you multiply your bases. So yeah, hopefully that's not too crazy. But yeah, hopefully that kind of like breaking it down like this, right? Because 2 times 12 would get you to 24 inches for that like one edge of it in inches, right? 2 feet is the same as 12 inches. But since it's a cube with 3 dimensions, then it's just 24 cubed, right? 2 times 12 is 24, and then you cube it, so that's 24 cubic inches right there. And we probably want to say inches. Oh no. We would say pounds for this one. LBs for that one. Forgot the units. Okay, so now we have finding the power of a power. I call this the power rule, right? Product rule, power rule, right? Now this second one is kind of a subset of the product rule. Like the first 2 examples are kind of related. I mean, they're all related because they're exponents, but so finding the power of a power. So we're taking 5 squared to the power of 4, right? And we can see what's different, hopefully, between this first example where we have 2 cubed times 2 to the 6. There's kind of like two bases right here, but this one only has 1 base, right? So we're taking that 5 squared times the power of 4, or to the power of 4, not times the power of 4. So I'm going to expand this out, and when I say expand it out, this is called expanded form, like this, or like this. Okay. So 5 squared means I have 2 5s multiplied together. 5 times 5, and then I have 4 groups of that, right? So times 5 times 5 times 5 times 5 times 5 times 5. Now we have 4 of the same group, and now we just count it out, right? 1, 2, 3, 4, 5, 6, 7, 8. So that means I have 8 5s. And how do you get from 2 to 4? You multiply, right? So when you're taking a power to a power, you keep your base the same. Okay. Right, so our base is 5. It's going to stay 5. And you multiply your exponents. And I'll say the. Let's keep. I don't want to keep switching from your and that doesn't make any sense. So yeah, when you have kind of two separate ones and you're multiplying them together, that's when you add your exponents. But when you have one base and you're kind of taking to a power of a power, that's when you multiply your exponents. Yeah, guys, I don't know. It's about the extent of it right there. Let's do. I wonder if red will show up with orange. Kinda. Yeah, it works. Yeah. Okay. Now this in the past I have called this the quotient rule. And this is similar to the power rule, right? It's kind of the inverse or the opposite of it, right? So instead of, the opposite of the product rule right here, because rather than multiplying them together, we are dividing them, right? And so I'm going to expand this out, and I'm going to have 5 sixes here. 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. And then I'm going to be dividing by 3 sixes. Okay. And hopefully you realize that 6 divided by 6 is 1. So we can kind of just cancel that out. Dun, dun, dun. Cancel out that one, because that's 1, right? 6 divided by 6 is 1. Cancel that one out. And now we have 2 6s left, which is 6 squared. Okay? So let's kind of compare here, right? If when we were multiplying, we added our exponents. If you are dividing, you can subtract your exponents, right? 5 minus 3 is 2. So you're going to keep the base the same. And you are going to subtract your exponents. Okay? Just like that. All right, let's see how much time we got here. Okay, I had kind of a corollary on here. I think I might start doing this more often in notes. Okay, so this is kind of, it broke it down just kind of all at the same time, right? So for the product of powers, like when you're multiplying them together, that's when you add, right? When you have the same this is basically same base, different exponents. That's when you add them, right? Now, when you have a different base but same exponents, you multiply your bases together and keep the exponent, right? This is exactly what I wrote on the front, right? To find the power of a power, you multiply your exponents. And when you are dividing, this is when you subtract your exponents. So this right here is kind of a little, I don't know, collection summary of all the rules that we just went over, okay? What I'd like you to do is kind of just go through these and kind of write how do properties of integral exponents help you write equivalent expressions. Yeah, I don't know. Like you could look at like if I had like, let's do something here. If I had like, I don't know, let's say x to the 4th times x squared, right? Since they're being multiplied together, all I do is add the exponents. I end up getting x to the 6th. Now that x to the 6th is technically the same as x to the 8th divided by x squared, right? Because I subtract the exponents, right? So those are equivalent expressions, right? I can get to the same answer kind of using different ways, like that. So, yeah, like look for relationships. If you're writing an equivalent expression for 2 cubed times 2 to the 4th, how many times would you write 2 as a factor? So basically, how many 2's do you have, right? Since you're multiplying them together, you add your exponents to get to 7. So you would write 7 2's, 7 of them. Kristen wrote 5 eighths as an expression equivalent to 5 squared to the 4th. Her math partner writes 5 to the 6th. Who is correct? I don't know. Figure that out, right? If it's power to a power, which one is that? That is this one right here. That's when you multiply your exponents, right? So it looks like Kristen is correct because she multiplied them rather than her math partner who had 5 to the 6th. So It would be Kristen. And then Tyler says that an equivalent expression for 2 cubed times 5 cubed is 10 to the ninth. Is he correct? Explain. No, he's partially correct, right? When you have the same exponent but different bases, you multiply your bases. So 2 times 5 is 10, but you do not multiply your exponents, right? So when we're doing this, right, this is kind of this example right here. Multiply your bases, keep the exponents the same, right? So rather than 10 to the ninth, it's going to be 10 cubed, right? He should not have multiplied his exponents. So that's the idea here. Okay. All right. So let's just try these out. You can kind of, I'd like you to actually try these on your own and come back and check your work. So write an equivalent expression for 7/12 times 7 to the fourth. Since we're multiplying together, I know that I keep the base the same and add the exponents. 12 plus 4 is 16, right? 12 plus 4 is kind of an interim step. Write an equivalent expression to 8 squared to the power of 4. This becomes 8 to the 2 times 4, which is 8 to the 8th. A billboard has these dimensions, 7 squared by 4 squared. Using expressions, write 2 equivalent expressions for the area of the rectangle. So I've got 7 squared times 4 squared. So that's one equivalent expression. And then when I kind of combine them together, I get to 28. Come on, if I could actually write 28 squared. 7 times 4 is 28. And then you keep the exponent the same when you have a situation like that. Write an equivalent expression for this was the quotient rule where we subtract our exponents. So it's 18 basically to the 9 minus 4, which is 18 to the 5th. Yeah. Hopefully you feel okay about that. Now I'm going to put this into the notebook here. This is going to go on page 11. This is 1-6. What do I call this? Use properties of integer exponents. Oh, and since I have 2 pages, oh man, that's EX very separated. I'm going to put it on 11 and 12, and we'll note that in the table of contents. And so 12. Boom. Okay, so fold this in half, hamburger style, right? El estilo de hamburguesa. It's like so. I guess we're cutting off my day 5 bit. That's fine. All right, so I'm just going to put that right there. Where did I put my glue? Like so. All right, and then for the second page, I'm going to do the same thing. I fold it in half with kind of the blank pages out. And then I put that on the next page. So right there. Okay, now for the, let's see, 11 to 12, the pages. I'm going to say 1-6. Use properties of integer exponents. This is 11 through 12.